Stone walls once defined the limits of power in the medieval world, but a group of brilliant minds, the siege engineers, learned to crack their secrets wide open. This is the story of how catapult masters outsmarted castles through ingenious tricks that transformed warfare. You will discover the hidden intellect behind the destruction, seeing these ancient conflicts in a completely new way by the end. How did they turn a fortress's greatest strength into its fatal weakness? And what does it take to mentally dismantle a stone giant piece by piece? What do you believe separates a simple attack from a true work of strategic art? A castle was far more than just a pile of stones. It was a deeply layered puzzle of defensive genius, each piece designed to break an enemy's will. The first and most obvious challenge was the sheer height and thickness of the outer walls. These stone giants were not simple barriers. They were often 10 or even 20 feet thick, built to absorb the brutal punishment of any known weapon. But the walls were only the beginning. Surrounding them, a wide, water-filled moat served as a formidable ditch, forcing attackers to contend with yet another obstacle before they could even reach the stone. The only way across was a heavily fortified gatehouse, protected by a drawbridge that could be lifted away and a portcullis, a massive iron grating that would crash down from above. And if an attacker somehow made it through that deadly funnel, they would find themselves in a narrow courtyard, exposed to a rain of arrows, rocks, and boiling liquid poured from openings in the ceiling known chillingly as murder holes. Every single element, from the water in the moat to the height of the towers, was calculated to inflict maximum delay and casualties on any assaulting force. It was a system that seemed almost perfect, a testament to defensive engineering. Yet for the siege engineers staring up at these formidable structures, perfection was merely a challenge waiting to be solved. Each powerful defense in its very design contained the subtle hints of its own downfall. These specialists were the ultimate problem solvers, their minds sharper than any sword. A siege engineer was a master of multiple disciplines, combining a deep understanding of mathematics, physics, and architectural design into a single, devastating profession. They were not tied to any one king or country. Instead, they were often itinerant experts, traveling from one conflict to the next, selling their invaluable services to the highest bidder. Their true worth lay in a unique skill, the ability to stand before a massive castle and, through careful observation, diagnose its hidden weaknesses. They would note the angle of a wall, the composition of the stone, even the subtle settling of the ground beneath the foundations. This was not a job for a brute, it was a role for a brilliant analyst. After their assessment, the engineer would devise a complete assault plan. They then commanded large teams of laborers and soldiers, directing the complex construction of siege works and the operation of the mighty engines of war. Their expertise went far beyond simple construction. It was about the precise application of force, knowing exactly where and how to strike to make a fortress crumble. This professionalization of siegecraft represented a fundamental shift in warfare, moving the advantage from sheer muscle to calculated, intellectual strategy. And the primary instrument of their intellectual victory was the catapult. The true genius of the catapult was hidden in its mechanics. These were not simple machines for hurling rocks at random, but precision instruments built on the fundamental laws of physics. The most formidable of them all was the Trebuchet, a masterpiece of engineering that transformed the potential energy of a massive counterweight into devastating kinetic force. Picture a giant lever with a heavy box filled with tons of stone or lead on one end and a sling holding a projectile on the other. When the counterweight was released, it dropped, whipping the long throwing arm upward and launching its payload in a high, precise arc. The engineers had to perform complex calculations in their heads, determining the exact weight needed for the counterweight, the perfect length for the throwing arm, and the precise angle of release to ensure the stone landed on the same vulnerable section of wall over and over again. This was not guesswork, it was applied mathematics. This deep, intuitive grasp of physics, the ability to predict the flight of a projectile with remarkable consistency, is what truly separated the master engineers from the amateurs. It was this consistent, calculated bombardment that could turn a castle's greatest strength into its fatal weakness. How could a structure designed to withstand immense force begin to fail under such a relentless, intelligent assault? Their first task was a silent, patient study of the stone giant before them. These masters of the catapult understood that a castle, like any structure, had its own unique anatomy of stress and strain. They would spend days, sometimes weeks, observing every contour, searching for the subtle tells of vulnerability. A section of wall that appeared newer or of a slightly different color hinted at a past repair, a potential weak spot where the masonry might not have fully bonded. They paid close attention to corners where two walls met, as these junctions could be less reinforced than the straight stretches. Even the mighty gatehouses and soaring towers, symbols of defensive power, were scrutinized for their hidden flaws. A tower might be incredibly strong from the front, but its curved shape could create blind spots, areas where a well-placed projectile could strike with shattering effect. This was not a search for random destruction. It was a hunt for efficiency. By identifying the precise points where the castle's own design worked against it, the engineers could achieve catastrophic results with far less effort. A single stone hitting a repaired section could start a crack that would spiderweb through the wall, while a strike on a tower's weak point could destabilize its entire structure. This meticulous targeting was the intellectual core of the siege, transforming a blunt instrument into a surgical tool. Once these weaknesses were mapped in the engineer's mind, the real work of orchestrated collapse could begin. But the stones themselves were only one part of the target. The true masters of the siege understood that the most critical weakness of any fortress was not its stone walls, but the human minds defending them. They waged a relentless campaign of psychological warfare, designed to erode the will of those inside long before the walls finally fell. A trebuchet could launch more than just boulders. In a horrifying twist, engineers would sometimes load the slings with the carcasses of diseased animals, hurling pestilence and decay over the walls to spread sickness and terror. On other occasions, they launched the severed heads of captured soldiers back into the castle, a brutal message meant to crush any lingering hope of rescue. The bombardment itself was a powerful psychological tool. The constant, thunderous impact of stone against stone was not just destructive, it was deeply disorienting. It shattered sleep, frayed nerves, and created a climate of constant, gnawing anxiety that left defenders exhausted and unable to function at their best. The engineers manipulated this fear with chilling precision. Sometimes they would intentionally fire their shots to land harmlessly in a courtyard or a moat for hours on end, lulling the garrison into a false sense of security. Then, without warning, a single, perfectly aimed shot would smash into the battlements with devastating effect. This unpredictability kept everyone inside in a state of perpetual tension, never knowing when or where the next lethal blow would land. This mental manipulation, the systematic breaking of human spirit, was often the decisive factor in a siege, and one of their most ingenious tricks involved a masterful act of deception in their very targeting. They would often begin their assault with a masterful lie, The first stones to fly from a master engineer's trebuchet were not always aimed at the weakest point. Instead, they would deliberately target a strong but less vital section of the ramparts. This created a powerful illusion for the defenders watching from the walls. Believing they had identified the enemy's main objective, the garrison commander would urgently shift his best men and resources to reinforce that area. Soldiers would be pulled from other posts, wooden barricades would be hastily erected, and all attention would focus on the spot where the rocks were falling. This was exactly what the engineer wanted. After this feint had fully captured the enemy's focus, the real attack began. The massive machines would fall silent for a moment, their crews making subtle adjustments. Then, with a chorus of creaking wood and whirling slings, the bombardment would suddenly shift. Heavy stones now rained down upon a completely different and far more vulnerable part of the castle's defenses. The defenders, now stretched thin and committed to the wrong location, were caught completely off guard. They could not reorganize fast enough to meet the new, genuine threat. This tactical deception was a brutal game of chess played out with stone and steel. By using lighter projectiles for the initial diversion and saving their most massive boulders for the true breach point, the engineers conserved their strength for the killing blow. This was not mindless destruction. It was a calculated performance designed to manipulate the enemy's movements and break their defensive cohesion before a single ladder was ever raised. Fire could become a weapon as terrifying as any stone. When a castle proved too resilient to battering alone, the siege masters would unleash a different kind of horror from their catapults, one designed to burn and choke. They loaded their slings with incendiary projectiles, carefully crafted bundles of chaos. These were not simple torches. Some were pots filled with a mysterious, sticky compound known as Greek fire, a substance that water could not extinguish and that clung to whatever it touched, burning fiercely. Others were tightly wrapped bales of straw and rags, soaked in tar or pitch, which would ignite into a roaring ball of flame upon impact. A third, more insidious weapon was quicklime, a fine powder that, when launched in clay pots over the walls, would react violently with the moisture in the eyes and lungs of the defenders, creating a blinding, choking dust cloud. These fiery missiles transformed the castle's interior into a landscape of terror. A single well-aimed shot could set a thatched roof ablaze, threaten precious grain stores, or destroy the wooden hoardings that defenders built out from the walls for protection. The resulting fires did more than just burn wood and stone. They forced a terrible choice upon the garrison. Soldiers who should have been manning the battlements against assault now had to drop their weapons and form desperate bucket brigades, frantically fighting the flames spreading through their own home. This diversion of manpower was precisely the engineers' goal. It created gaps in the defensive line, moments of chaos and confusion that could be exploited. Thick, acrid smoke from the burning structures would often billow over the walls, creating an artificial fog that blinded the defenders. Under this smokescreen, other units like sappers with their mining tools or infantry with scaling ladders could advance with much greater safety. This was the true mark of a siege master, the ability to orchestrate a multi-faceted assault where fire, fear, and force worked in a devastating concert. But the manipulation of destruction did not end with what they launched. It also depended profoundly on how and from where they launched it. Precision in range was the hallmark of a true master. A great siege engineer never settled for a single, predictable distance. Their true skill was revealed in how they constantly adjusted the trajectory of their shots, probing the castle's defenses like a physician searching for a pulse. They would often begin the assault with long-range volleys, sending heavy stones in a high arc to crash against the outer walls and towers. This initial phase was a critical test. It revealed the strength of the masonry, it gauged the defenders' reactions, and it mapped the castle's defensive reach. Where did the counter-fire from the walls fall short? Where were the garrison's archers most concentrated? Every impact provided valuable information. Then, the engineers would begin to close the distance. By carefully adjusting the massive counterweight on a trebuchet or the torsion on a mangonel, they could shorten the range with meticulous control. Moving closer allowed for a flatter, faster trajectory and dramatically increased accuracy. A stone that once slammed into a wall face could now be aimed to fly just over the crest of the battlements, crashing down directly onto the walkways where defenders stood, or even soaring into the inner courtyards to strike at storage buildings and barracks. This flexibility was a devastating form of psychological warfare. The defenders could never feel safe. A soldier might believe he was protected by a high parapet, only to discover that the enemy could now drop a projectile directly into his sheltered position. This relentless adjustment forced the garrison to constantly shift their own resources, creating confusion and exposing new weaknesses for the engineers to exploit. But even this mastery of trajectory had its limits against certain defenses, which is why the most ingenious engineers developed an entire arsenal of specialized ammunition. The true versatility of a siege engine was revealed not in its structure but in what it threw. Master engineers were artisans of ammunition, customizing their projectiles with a chilling creativity to achieve specific tactical goals far beyond simple battering. A round stone was effective, but a shaped one could be devastating. They carved stones into rough cubes or multifaceted forms, creating projectiles that, upon impact, would bite deeper into masonry and transfer their energy more efficiently, cracking walls open instead of just chipping the surface. For wooden hoardings or gatehouses, they swapped stone for sharpened, fire-hardened logs or massive metal-tipped bolts, designed to splinter defenses and impale anyone sheltering behind them. Yet their ingenuity turned truly sinister with specialized payloads. They crafted hollow clay balls filled with a mixture of sulfur and other noxious chemicals. When these pots shattered against the stone, they released a thick, poisonous gas that choked and blinded defenders, forcing them to abandon their posts. In one legendary and cunning instance, besiegers grew so frustrated by archers on the walls that they loaded beehives into their trebuchets. The hives soared over the battlements, exploding in a furious, stinging cloud that sent the defenders into a panicked retreat, completely neutralizing that section of the wall without a single casualty. This level of customization meant every single shot could be a calculated decision. One volley could be for breaching, the next for demoralizing, and a third for spreading chaos and disease. Each specialized projectile was a direct answer to a specific defensive problem, showcasing a mind that saw the entire battlefield as a series of puzzles to be solved. But for the most patient and cunning of these masters, the ultimate solution lay not in what they launched over the walls, but in what they did beneath them. The most devastating sieges were symphonies of destruction, with each element playing a specific part in a coordinated performance. While the catapults thundered above, a silent, invisible war was being waged below the ground. Teams of specialists known as Sappers were digging their way towards the castle's foundations, and their success depended entirely on the chaos created by the bombardment. The constant, deafening impact of heavy stones against the walls served a dual purpose. It masked the telltale sounds of digging, the scrape of shovels and the thud of picks, preventing the defenders from hearing the approaching danger. Just as importantly, it forced the garrison to keep their heads down behind the battlements for fear of being crushed by the next projectile, which dramatically reduced the risk of arrows or dropped rocks hitting the sappers as they worked. This was a masterstroke of military coordination, a perfect synergy between the brute force of the catapults and the stealthy precision of the miners. The sappers' work was dark, claustrophobic, and incredibly dangerous. They would dig a narrow tunnel, shoring it up with wooden timbers as they went, until they reached directly beneath a critical section of the wall, like a corner or a tower. There they would excavate a large chamber, filling it with combustible material like dry brush and timber. Once everything was ready, the final, terrifying phase began. The sappers would set the chamber ablaze and make a frantic retreat. The fire would consume the wooden supports, and as they turned to ash, the ground above would have nothing left to hold it up. The massive weight of the stone wall would suddenly drop into the void, creating a catastrophic breach. From the defenders' perspective, it must have been a scene of pure horror. One moment, the wall was standing strong. The next, it was collapsing into a heap of rubble and dust without a single trebuchet stone having struck it. This coordinated assault demonstrated a chilling level of strategic foresight. It proved that the greatest threat to a castle was not one single weapon, but a commander who could orchestrate multiple threats to strike at the same time from different directions and on different planes of battle. Yet none of this intricate coordination would have been possible without one crucial, often overlooked element: the success of every feint, every specialized projectile, and every synchronized attack hinged on a deep and intimate knowledge of the enemy fortress. How did these master engineers, often outsiders to the region, gather the intelligence required to plan such devastating campaigns? Information was the true currency of siege warfare. Before a single timber was cut for a trebuchet, the masters of the siege were already at work, wielding a weapon far subtler than any catapult: espionage. They dispatched agents, often disguised as merchants, pilgrims, or deserting soldiers, to infiltrate the area around the castle. These spies were the eyes and ears of the engineer, tasked with gathering intelligence that would transform an assault from a blunt gamble into a precise operation. They listened to the gossip in nearby taverns, learning about the garrison's morale. Were the soldiers well-fed and confident, or were they grumbling about low supplies and a harsh commander? They observed the castle itself, noting if the well was drawing muddy water, a sign of a failing water source, or if certain sections of the wall showed fresh, hastily applied mortar from recent repairs. Most importantly, they studied the routines of the defenders. They learned the exact times when the watch changed, when the main meal was served, and when the night guards were at their most tired and inattentive. This intelligence was a blueprint for exploitation. An engineer who knew the garrison's schedule could time his first, shocking bombardment for the precise moment the day watch was leaving their posts and the night watch was still rubbing sleep from their eyes, creating maximum chaos and confusion from the very first strike. Spies might also discover the location of a hidden postern gate, a small, concealed door used for sorties, which could then be targeted for a surprise assault or blocked to trap the defenders inside. This emphasis on information warfare meant the real battle often began weeks before the first stone flew, giving the masters a psychological and strategic advantage that was often impossible to overcome. But even the most detailed human intelligence could be undone by the whims of nature, which is why the wisest engineers also learned to read the sky. They turned the weather itself into a weapon. A seasoned master knew that a dense morning fog was not an obstacle, but a gift. It provided a perfect smokescreen, allowing his laborers to advance siege towers or fill in sections of the moat with relative impunity. A strong wind blowing towards the castle was not an annoyance, it was an ally. It could carry the acrid smoke from their own campfires into the defenders' eyes, blinding them, or it could increase the range of their projectiles, allowing them to strike deeper into the fortress from a safer distance. Even rain had its uses. A prolonged downpour could swell the moat, making it seem more formidable, but it could also soften the ground, helping sappers dig their tunnels more easily, and sometimes even undermining the castle's foundations through slow, silent erosion. The true genius of these siege masters lay in their adaptability. They did not just fight the castle, they integrated the entire environment into their strategy, using every available element from human routine to the very climate to tighten the noose around their stone giant. A master siege engineer knew that the weather was never just a condition to endure, it was a tactical variable to command. Rain, often seen as a boon for defenders with its ability to quench fires, could be twisted into a weapon. These experts would launch their incendiary pots during or immediately after a downpour. Why? Because a castle's thatched roofs and wooden structures, soaked and heavy with water, were far less likely to burst into quick, visible flames. Instead, the sticky, water-resistant compounds like Greek fire would cling to the wet surfaces, smoldering and producing thick, choking smoke that would seep into buildings and tower interiors, creating an unbearable atmosphere long after the rain had stopped. Wind direction was another critical calculation. Before launching projectiles filled with quicklime or pots designed to release noxious smoke, the engineer would wait for a steady breeze blowing directly toward the castle's heart. This transformed a simple launch into a targeted gas attack, carrying the blinding, choking cloud deep into the courtyards and forcing defenders to abandon their posts. A thick morning fog was an invitation to advance. Under this natural cloak, work crews could quietly dismantle outer palisades or, more daringly, drag the massive catapults themselves hundreds of yards closer to the walls, effectively cutting the range in half without the defenders ever knowing they were there. Even the deep cold of winter played its part. A severe frost made stone blocks contract and become more brittle. A heavy trebuchet shot striking a frozen wall did not just chip the surface, it could send cracks racing through the masonry like lightning, compromising the structure's integrity with far fewer impacts. This deep integration with the environment, this ability to see rain, wind, and frost not as obstacles but as tools, separated the true artist of siegecraft from the mere mechanic. Yet their manipulation did not stop with the elements of nature. It extended to the very perception of time itself, stretching a defender's endurance to its absolute limit. The most unnerving sound for a defender was not the constant roar of bombardment, but the silence that fell between the strikes. Master engineers perfected a strategy of intermittent fire, turning the very rhythm of the siege into a weapon of psychological torture. Instead of a relentless, predictable barrage that would exhaust their own crews and rapidly deplete their precious ammunition stockpiles, they would launch sporadic volleys at completely irregular intervals. 1 hour, 3 stones might crash against the wall in quick succession. The next 2 hours, there would be nothing but an eerie quiet. This unpredictability was devastating to the human mind. Defenders could never relax, never let their guard down. Just as they began to believe the assault was over and dared to emerge from cover to assess the damage or snatch a moment of rest, another thunderous impact would shatter the calm. This constant state of high alert, this cycle of tension and false relief, frayed nerves and eroded morale more effectively than any non-stop attack. For the engineers, these pauses were not downtime. They were critical observation periods. From their vantage points, they would study the fresh damage caused by the last volley, looking for new cracks or shifts in the masonry. This allowed them to make minute adjustments to their machines, refining their aim for the next, more effective strike. They were conserving their strength and their best ammunition, husbanding their resources for a final, overwhelming assault on a section of wall that was already groaning under the strain. This calculated patience, the ability to wield silence as powerfully as sound, was the mark of a true strategist. Yet, the defenders were not passive victims in this deadly game. They developed their own ingenious countermeasures, forcing the catapult masters to constantly innovate their attacks. A castle's own artillery posed the deadliest threat to the masters' precious siege engines. Perched high on the walls, defensive ballistae and catapults could rain destruction down upon the besiegers' own machines, shattering timber and crews in a matter of moments. To counter this, the engineers engaged in a deadly duel of wits and accuracy. They would order their best crews to target these specific defensive positions with relentless, high-precision fire. Instead of massive boulders, they often switched to smaller, denser stones or even heavy metal bolts, projectiles designed for speed and pinpoint impact. The goal was not to batter the wall, but to smash the delicate wooden throwing arm of a trebuchet, or to splinter the torsion frame of a ballista with a single, well-placed shot. In a brilliant act of deception, they sometimes constructed dummy catapults from rough timber and canvas, placing them in clear view of the defenders. These decoys, looking every bit like the real threat, would inevitably draw the castle's counterfire, wasting the garrison's ammunition and, more importantly, revealing the positions and range of their artillery. Once those positions were known, the real siege engines, carefully concealed or repositioned, would unleash their fury upon them. Silencing the castle's ability to strike back was a tactical priority that transformed the entire battlefield. With the enemy's artillery neutralized, the masters' crews could work in relative safety, methodically pounding the same section of wall for days without interruption. This proactive defense of their own offensive capability was what allowed a siege to maintain its relentless, grinding pressure, and this pressure was not only applied through force, but through a clever manipulation of the very land the castle stood upon. A master engineer saw the landscape itself as a weapon. The positioning of a catapult was never left to chance. It was a deliberate calculation that could decide the entire siege. These specialists always sought the high ground. Placing their engines on a hill or ridge provided two critical advantages. First, it dramatically increased the effective range of their shots, allowing a stone to fly farther and strike deeper into the castle grounds. Second, and just as importantly, it gave the engineers an unobstructed view of the entire battlefield, letting them observe the impact of every shot and adjust their aim with deadly precision. But visibility was a double-edged sword. A catapult silhouetted on a hilltop was a perfect target for the castle's own artillery. So, when high ground was not available or too exposed, the engineers turned to natural cover. They would nestle their massive trebuchets within the edges of a forest, using the dense canopy to hide their construction and break up their outline. They positioned them behind hills, using the terrain as a natural shield that absorbed or deflected incoming projectiles. For additional protection, they constructed their own defenses. Crews would build massive earthwork berms, tall mounds of packed soil, in front of their engines. Others erected wooden screens covered in wet hides, designed to smolder rather than burn, providing a physical barrier against arrows and small stones. This careful placement went beyond mere protection. A truly brilliant engineer would position his batteries to enfilade the castle walls. This meant setting up a catapult so that its projectiles flew parallel to the length of a wall, rather than striking it head-on. A stone hitting a wall directly might chip a small crater, but a stone flying along its length would scrape across the entire face, damaging battlements, shattering arrow loops, and clearing the walkway of defenders in a single, devastating pass. This strategic use of the land multiplied the force of every shot, turning the natural world into a silent ally. Yet, even the most perfectly placed catapult was a tool of immense and costly force. The masters knew that sometimes the most effective siege was one that barely fired a shot, relying instead on a slower, more insidious form of pressure that targeted the enemy's purse rather than their walls. A castle could starve long before its walls fell. The most brilliant siege engineers understood that a fortress was not just a military structure, but a living, breathing economy. They learned to aim their catapults past the battlements, targeting the very heart of the castle's endurance. Their stones were now aimed at the granaries and storerooms, where precious months of food were kept. A single well-placed shot could rupture a grain silo, spoiling the harvest and starting a clock of hunger inside the walls. They targeted the kitchens and bakeries, not just to destroy meals, but to eliminate the means of preparing them. Even the workshops and forges became prime targets. Destroying the blacksmith's anvil and bellows meant no new arrows could be fletched, no broken swords could be repaired, and no new nails could be made to fix the damaged gates. This was a war of attrition fought with stone and strategy. The defenders now faced an impossible choice. Do they keep every available man on the walls to repel assaults? Or do they send teams into the dangerous courtyards to fight fires in the granary and salvage what food they can? This internal conflict over resources could breed resentment and discord between soldiers and civilians, fracturing the community's will to resist from the inside out. A garrison might hold a breach for weeks, but it could not fight without food, water, or tools. By making the castle an unsustainable place to live, the engineer could force a surrender without ever planting his banner on the main wall. This economic targeting revealed a profound shift in thinking, where victory was measured not in feet of collapsed masonry, but in the dwindling supplies and broken morale of the people within. Just as this pressure tightened its grip, the masters had one final, brilliant trick to play, one that manipulated the defenders' deepest expectations of the battle itself. A master siege engineer's greatest weapon was often the illusion he created. By deploying multiple catapult batteries across the battlefield, he could orchestrate a grand and confusing performance. One battery positioned to the east might thunder away for hours, hammering relentlessly at a section of the outer wall. To the defenders, this seemed the clear and obvious focus of the assault. Their commander would logically shift his best archers and stockpile of defensive rocks to that very spot, bracing for the inevitable breach. Yet this was all a carefully staged show. That noisy, active battery was merely the bait, concealed in a wooded area to the north or hidden behind an earthwork to the south. A second, more powerful battery stood silent, its crew resting and its massive counterweight poised. Then, at a prearranged signal, the first battery would fall quiet. In the sudden, unnerving silence, the second battery would unleash its first volley, its stones crashing against a completely different and utterly unprepared section of the fortress. The defenders, now stretched thin and committed to the wrong location, were caught in a terrible scramble. They could not reposition their heavy defenses quickly enough. This bait-and-switch tactic did more than just confuse the garrison, it physically exhausted them. While one catapult crew was firing, the other was resting, rotating fresh teams to maintain a pace of bombardment that a single, overworked crew could never hope to match. This rotation ensured the pressure was relentless, giving the defenders no reprieve. The organizational skill required for this deception was immense, demanding precise timing and clear communication across vast distances. And that communication, the silent language of flags, runners, and signal fires, was the invisible nerve center that made every trick and feint possible. Silence was a weapon, and so was a single-colored flag. The intricate coordination of multiple catapult batteries, of feints and sudden shifts in target, all hinged on a swift and secret system of communication. Master engineers could not rely on shouted commands that would be lost in the wind and the thunder of impacts. Instead, they developed a sophisticated language of signals. A runner sprinting from a hidden observation post might deliver a scribbled note with a new angle of fire. A sequence of horn blasts, each with a distinct pattern, could order every crew on the line to switch to incendiary ammunition. But the most common tool was a set of brightly colored flags, waved from a central command post in clear view of all the battery commanders. A red flag raised high might mean to increase range by 50 paces. A blue flag crossed over a yellow one could signal a synchronized volley on the count of 3. This precise control transformed a collection of individual machines into a single, intelligent organism. A breach spotted in a distant tower could be communicated and targeted by every catapult within minutes, concentrating an overwhelming force on the new weakness before the defenders had time to react. This system was the invisible nervous system of the entire siege, the glue that held every brilliant trick together. And when those flags signaled a timed barrage, they created a psychological weapon all its own. The crews could establish a predictable rhythm of fire, a stone every 10 minutes, lulling the defenders into a trance of expectation. Then, as the garrison relaxed into the pattern, the flags would drop. The predictable rhythm would be shattered by a sudden, simultaneous salvo from every engine, a storm of stone that crashed into the walls without warning. This orchestrated chaos, born from perfect order, broke more than just stone. It shattered the last vestiges of defensive cohesion. Yet, for all their power against towering walls, the catapult masters faced a unique challenge when the strongest point of a castle was not its height, but its front door. The mighty Gatehouse demanded a completely different kind of ingenuity. The Gatehouse presented a paradox, a fortress within a fortress that was also its most inviting target. While its thick doors and iron portcullises were formidable, they were fundamentally designed to open and close, a necessary flaw that siege engineers were eager to exploit. Unlike a solid wall that could absorb punishment, the complex machinery of a gatehouse was fragile. A massive, ram-like projectile launched from a trebuchet could splinter the thickest oak gate, or, even more effectively, smash the heavy windlass and chains that controlled the portcullis, jamming it permanently in its tracks. Incendiary shots were equally devastating here. A single clay pot of Greek fire, shattering against the wooden drawbridge or the gatehouse doors, would ignite a blaze that was almost impossible to extinguish, consuming the very heart of the castle's access control. The strategic brilliance of this focus was twofold. First, breaching the gate offered a direct, open path for infantry, avoiding the costly and slow process of scaling walls or waiting for a mine to collapse a section of the ramparts. Second, and just as important, it forced the defender's hand. The garrison commander had no choice but to pour his best soldiers and resources into protecting that single, vital choke point. This concentration of defense at the gate left other stretches of the wall undermanned and vulnerable. An engineer could then use his other catapults to quietly and methodically pound a distant, neglected tower, knowing the enemy's attention was firmly fixed elsewhere. This manipulation of the enemy's focus was a recurring theme in their playbook, and they refined it into an art form through a simple, grinding tactic: the power of relentless repetition. This relentless precision found its ultimate expression in the method of repeated strikes. A master engineer would select a single, vulnerable point on the wall, perhaps a seam between two types of stone or a section weakened by past repairs. He would then order his crews to target that exact spot, and only that spot for hours, sometimes even days on end. The first massive stone would slam into the masonry, leaving a crater and a web of fine cracks. The next stone, landing in nearly the same place, would deepen that crater and force the cracks to spread wider and deeper into the wall's core. Each subsequent impact was a hammer blow on the same anvil, working the stone like a blacksmith works metal until the internal structure fatally failed. To achieve this incredible consistency, the engineers used simple but brilliant tools. They would plant aiming stakes in the ground at a calculated distance, lining up the throwing arm of the trebuchet with these markers for every shot. They might also use a fixed sightline, like a notch in a tree on a distant hill, to guarantee the projectile's arc never wavered. This was a test of patience as much as power, a grinding, methodical process that demanded unwavering focus from the entire crew. The defenders could only watch in helpless dread as their wall, once a symbol of impregnable strength, was systematically dismantled block by block. The cumulative effect of this focused energy was undeniable, a physical testament to the principle that relentless, intelligent pressure will always overcome brute, static strength. Yet, just as this predictable, grinding assault taught defenders where to expect the final breach, the most cunning engineers had a final, brilliant card to play, one that relied on shattering every expectation of timing and location. Darkness itself became a tool in the master's arsenal. Under the veil of night, the rules of the siege shifted dramatically. A castle's defenders, reliant on the sharp eyes of their lookouts, were suddenly blinded. Spotting the dark arc of an incoming stone against a black sky was nearly impossible, making return fire from their own catapults a matter of pure guesswork. This limited visibility was a green light for the engineers. Under this protective cloak, work crews could drag the massive trebuchets hundreds of yards closer to the walls, effectively halving the distance and transforming their engines into point-blank instruments of destruction. They could also reposition entire batteries, silently moving them to target a new, unsuspecting section of the fortress by first light. But the most devastating use of the night was the shock of a sudden, thunderous barrage. After hours of unnerving silence, the violent crash of stone against the battlements in the dead of night could shatter the garrison's morale. Soldiers, startled from their sleep and disoriented in the confusing darkness, would scramble for their posts in a state of pure panic. It was in this window of chaos and disorganization that the engineers' ultimate blow often fell. Infantry, waiting in silent trenches, would launch a sudden assault on the very walls just shaken by the bombardment, scaling ladders against defenders who were still struggling to comprehend the attack. This tactic turned the human body's own need for rest into a fatal weakness, exploiting the circadian rhythm to break the will of the garrison from the inside out. Just as these masters perfected the art of attacking under darkness, they also faced a constant challenge from the bright spark of human ingenuity on the other side of the wall. The defenders were not passive. They constantly developed new technologies and countermeasures, forcing the siege engineers into an endless, fascinating duel of adaptation. Defensive walls began to change shape, literally. Builders started constructing them with slanted, angled faces, designed to make incoming stones skid off harmlessly or shatter on impact. They added massive outer earthworks called berms to absorb the initial shock of a projectile, and they built concentric rings of walls so that even if an attacker breached the outer bailey, they would find themselves trapped in a killing zone facing an entirely new inner fortress. For a siege engineer, these were not setbacks, they were interesting new puzzles. Their response was a masterclass in tactical adaptation. Against a slanted wall, a round stone was useless, so they began shaping their projectiles into heavy pyramidal blocks. These angular missiles would bite into the sloping masonry upon impact, transferring their energy directly into the wall instead of glancing away. When a castle used a soft, absorbent earthwork as a shield, the engineers switched their ammunition. They launched incendiary pots high over the berm, arcing them into the wooden structures behind it, or they used specialized digging shots designed to carve away the earthwork itself, slowly dismantling the defenders' buffer. The very concept of a target evolved. If the main walls became too tough, the engineers simply shifted their aim. Why waste energy on the reinforced gatehouse when you could destroy the barracks, the chapel, and the command center inside the inner ward? A garrison without a place to sleep, pray, or receive orders would quickly lose its cohesion and its will to fight. This was a perpetual arms race, a game of tactical one-upmanship where every defensive improvement was met with a clever, calculated countermove. The intellectual agility of these masters meant that a castle was never truly finished. Its defenses were only as good as the last innovation, and the enemy was always thinking one step ahead. This relentless pressure demanded more than just clever tricks, however. It required a vast and uninterrupted supply chain, a hidden world of logistics that kept the great engines fed and firing day after day. A master's grand designs were utterly dependent on a river of stone and timber flowing steadily to the front lines. While the trebuchets delivered thunderous blows, the true, unglamorous work of victory happened far from the walls, in bustling quarries and organized lumber camps. These engineers understood that a siege was a battle of logistics as much as it was a contest of force. They could not afford to run out of ammunition after a few days of spectacular bombardment, only to sit in silent humiliation while the defenders inside celebrated. So they mastered the art of the supply chain. Long before the first catapult was assembled, scouts would have identified local sources of stone. Teams of laborers would then work in shifts, tirelessly quarrying and shaping rough spheres, creating vast stockpiles that grew day by day. Other crews harvested entire forests, processing the wood not only for ammunition, but for the constant repairs the massive engines required. Workshops operated right on the siege line, with carpenters and blacksmiths ready to replace a cracked throwing arm or a frayed rope within hours. This relentless, organized productivity created a terrifying paradox for the castle's inhabitants. They could hear the endless, rhythmic sound of industry from the besiegers' camp, the distant chipping of stone and the sawing of wood, a constant reminder that the bombardment was not a finite event, but a sustainable, grinding process. The pressure was not just from the stones that hit the walls, but from the chilling certainty that the enemy outside had enough of them to continue forever. This logistical prowess meant the master could afford patience, turning the siege into a waiting game where the defenders' finite supplies of food and hope were always the first to run out. Yet this deep understanding of resources extended beyond wood and stone. It also applied to the human spirit inside the fortress. The most insightful engineers knew that a commander's personality could be a weakness to exploit. They practiced a form of medieval psychological profiling, tailoring their entire strategy to the man leading the defense. If intelligence suggested the garrison commander was reckless and prone to anger, the engineer might order a series of insulting provocations. He would launch rotting garbage over the walls or stage mock assaults that retreated just before contact, all designed to enrage the commander into ordering a foolish, costly sally out of the safety of the gates. Conversely, if the defender was known to be cautious and hesitant, the engineer would amplify that trait. He would create confusing signals across the battlefield, feint attacks in multiple directions at once, and maintain an unnerving, unpredictable tempo of bombardment. This would paralyze the cautious commander with uncertainty, preventing him from making decisive countermoves. The engineer was not just fighting a fortress, he was manipulating the mind of the person inside it, using their own character traits as the very lever to pry open their defenses. A commander's own temperament could become the very flaw that doomed his fortress. the most insightful siege engineers practiced a form of medieval psychological profiling, tailoring their entire strategy to the man leading the defense. Before the first catapult was even built, their spies would have gathered intimate details about the garrison leader. Was he a seasoned, cautious veteran or a young, glory-seeking noble? This intelligence was not mere gossip. It was a critical tactical blueprint. Against a commander known for his patience and methodical nature, the engineer would design a campaign of confusion. He would stage feints across a wide front, launching probing attacks on 3 different gates at once. He would maintain an unnerving, irregular rhythm of bombardment, with sudden silences that stretched for hours followed by a furious, concentrated barrage. The goal was to overwhelm a cautious mind with too many variables, paralyzing him with indecision and preventing any cohesive counter-strategy from forming. Conversely, if the defender was reported to be hot-headed and proud, the engineer would craft a strategy to exploit that impulsivity. He might order his men to shout insults across the moat or launch the severed heads of prized livestock over the walls as a deliberate insult. The aim was to provoke a rash sally, a furious charge out of the gates that would abandon the safety of the walls. When that happened, hidden cavalry and pikemen would be waiting to cut down the exposed soldiers, devastating the garrison's strength in a single, foolish engagement. This manipulation of human psychology added a profound layer to the siege. The engineer was no longer just calculating trajectories and stone weights. He was predicting human behavior, using a commander's own character as the lever to pry open his defenses. It was a chilling demonstration that the strongest walls could be undone by the weakest personality traits. And just as they mastered the human mind, they learned to command something even more intangible, the very air around them, by turning sound itself into a weapon. The very sound of the siege became a weapon in its own right. While the crash of stone against wall was terrifying enough, master engineers learned to orchestrate the acoustic landscape to heighten fear and disorient their enemies. They crafted specialized hollow projectiles, drilling holes or shaping clay pots to create a piercing, whistling shriek as they flew through the air. These screaming stones transformed an incoming volley from a visible threat into an invisible, psychological horror, their unnerving wail preceding the physical impact by crucial seconds. This constant auditory assault did more than just frighten. It systematically broke down the defender's ability to function. The relentless, thunderous noise made verbal commands on the walls impossible, isolating soldiers and fracturing unit cohesion. It shattered sleep patterns, leading to a deep, cumulative exhaustion that clouded judgment and slowed reaction times. In a truly cunning display, some engineers would coordinate their batteries to fire in a specific, rhythmic pattern. This manufactured thunder, a predictable boom, 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 would pound away at the defender's sanity, creating a sense of inescapable, grinding doom. This deliberate use of sonic intimidation reveals a profound grasp of multi-sensory warfare, where victory was sought not just through physical breach, but through the complete psychological collapse of the enemy. Yet, wielding such powerful and terrifying tools inevitably forced these brilliant minds to confront the moral weight of their own profession, navigating a complex landscape of honor, necessity, and the rules of war. Even the most brutal siege master knew that victory could be hollow if bought with endless blood. There existed a delicate, almost paradoxical, balance between mercy and terror. These engineers understood that a garrison pushed to the absolute brink, with no hope of survival, would fight to the last man, inflicting catastrophic losses on the attacking army. So they wielded surrender as a strategic tool. The tactic was a carefully choreographed performance. After days of relentless bombardment had visibly weakened a critical section of the wall, the engineer might order a final, concentrated barrage, a storm of stone and fire meant to demonstrate beyond any doubt that a breach was imminent and their power was absolute. Then, in the sudden, eerie silence that followed, a single, unarmed herald would walk toward the castle gates under a flag of truce. This was not a sign of weakness, but the ultimate display of confidence. The message was clear and stark. We have shown you we can destroy you. Now we offer you a choice. Spare your lives and the lives of those inside by surrendering now, or face utter annihilation when our soldiers storm through the breach. This offer was often surprisingly generous, allowing the defending soldiers to march out with their lives and sometimes even their personal weapons. Why be merciful? The calculus was coldly pragmatic. A long, bloody assault through a breach was costly for the attacker, risking the very army the commander needed for future campaigns. Accepting a surrender preserved the infrastructure of the castle, delivering a functioning stronghold rather than a ruined pile of rubble. It also established a reputation for fairness that could make the next castle on the campaign far more willing to negotiate, saving even more time and bloodshed. This strategic compassion, this ability to leverage fear into a negotiated victory, was a hallmark of the wisest masters, a final, ingenious trick that secured not just a castle, but a lasting legacy. The legacy of those medieval siege masters echoes far beyond the crumbling walls of forgotten castles. Their ruthless ingenuity fundamentally reshaped the very nature of warfare, establishing principles of applied science and psychological manipulation that military strategists still study today. In modern military academies, the core tenets of the siege engineer's craft are not relics, but foundational lessons. The relentless focus on precision targeting, the calculated use of deception to misdirect an enemy's resources, and the critical importance of adapting tactics to a specific opponent's weaknesses, all find their direct lineage in the Trebuchet masters who patiently mapped a castle's flaws. This was not mere destruction, it was the birth of systematic, intellectual combat. The very fortifications they fought against were forced to evolve in response, sparking a revolution in defensive architecture. The thick, high walls of the early Middle Ages gave way to the low, slanted, star-shaped bastions of the Renaissance, designed specifically to deflect cannon fire and eliminate blind spots, a direct consequence of the engineer's relentless targeting. This architectural arms race even influenced the design of cities, with urban planners incorporating defensive rings and clear fields of fire that can still be seen in the layouts of old European towns. Beyond the battlefield, the siege engineer's role as a multidisciplinary problem solver set a powerful precedent. They were the original systems analysts, blending physics, logistics, psychology, and material science to overcome a single, monumental challenge. This model of the innovative generalist, capable of synthesizing knowledge from diverse fields, paved the way for every technological and strategic leap that followed, from the complex campaign planning of Napoleon to the interdisciplinary teams behind modern innovations. Their ultimate legacy is a timeless testament to human ingenuity, proving that a focused, creative mind can dismantle any obstacle, no matter how imposing it may seem. What can we learn from their approach when facing our own modern fortresses, whether they are made of stone, steel, or seemingly impossible problems? These ancient strategies of pressure and precision are far from obsolete. The core principles that guided a siege master's campaign against a stone fortress are now being applied to dismantle modern fortresses of a very different kind. In the world of business, corporate raiders act as modern-day engineers, meticulously analyzing a competitor to find a single, critical weakness in their supply chain or product line. Instead of launching stones, they launch targeted marketing campaigns or price wars, applying relentless pressure on that one vulnerable point until the competitor's market position begins to crumble. Cybersecurity experts use the same logic, constantly probing a digital network for its softest target, knowing that a single unpatched software flaw can be the equivalent of a cracked section of mortar, allowing them to breach the entire system. This is not a coincidence, it is the enduring power of a systematic approach to problem solving. The Siege Master's mindset of ruthless efficiency, of using the minimum necessary force for maximum effect, is a lesson in resource management that resonates in any project with limited time and budget. Even the psychological warfare they perfected finds its echo in modern advertising and high-stakes negotiations. The careful building of brand desire mimics the slow erosion of a garrison's morale, while a negotiator's calculated feints and bluffs are direct descendants of the tactical deceptions used on the medieval battlefield. Their greatest legacy is a timeless blueprint for innovation, proving that the most imposing obstacles often yield not to brute force, but to a deeper understanding of their inherent flaws. Of course, our modern image of these brilliant minds is often clouded by persistent myths and Hollywood simplifications. Hollywood would have you believe that catapults were clumsy giants, hurling rocks at random with brute force alone. This popular image is a dramatic lie. These machines were not operated by mindless brutes, but by crews of highly trained specialists following the precise calculations of their master engineer. A single Trebuchet crew required men to manage the winding mechanism, others to load the massive counterweight, and a specialist to handle the sling and release mechanism. Each member had to perform his task with flawless timing, a symphony of coordinated effort where a single mistake could see a projectile drop harmlessly short or, worse, plummet onto their own line. The myth of inaccuracy is equally misleading. While not laser-guided, these engines achieved remarkable consistency through mechanical precision and practiced skill. A master engineer could reliably hit the same tower or even the same section of a wall throughout a long day of bombardment. This was not random destruction, it was a deliberate and methodical process. The second great myth is that sieges were nothing more than extended bouts of smashing. While destruction was a key component, the ultimate goal was rarely to reduce a castle to dust. It was to break the will of the people inside. The relentless bombardment, the psychological tricks, the feints, and the starvation were all parts of a sophisticated campaign of pressure and persuasion designed to force a surrender, which was almost always preferable to a costly, bloody assault. And defenders were far from passive. They were constantly innovating, building wooden hoardings out from their walls to drop stones on sappers, launching sorties to burn siege towers, and developing their own artillery to duel with the besiegers' engines. This dynamic, two-sided conflict was a high-stakes game of intellectual chess. Peeling back these myths does more than correct the historical record. It reveals the true nature of medieval warfare as a profound contest of minds. The greatest sieges were won not by the army with the most muscle, but by the commander with the sharpest intellect, the most creative strategies, and the deepest understanding of human weakness. This legacy of cunning and calculation is the Siege Master's true gift to history, a timeless lesson in how to dismantle the seemingly indestructible. Those medieval masters of the catapult were far more than just engineers of timber and stone. They were the complete strategists, weaving together the hard science of physics, the subtle art of human psychology, and the unglamorous discipline of logistics into a single, devastating profession. Their legacy is a playbook of ingenious tricks that feels startlingly modern, from their deceptive targeting that manipulated enemy movements to their acoustic warfare that shattered morale with engineered sound. This depth of strategic thinking transcends their own time, offering us a lens through which to view the intricate complexities of historical conflict not as simple clashes of force, but as profound intellectual contests. By studying their methods, we gain a much deeper appreciation for the true nature of medieval warfare and the timeless principles of strategic innovation. The next time you stand before the silent stones of a castle, look past its imposing walls and consider the brilliant, relentless minds that once sought to outsmart them, proving that no fortress, however mighty, is truly impregnable against human ingenuity. If you have enjoyed this journey into the minds of these ancient masters, subscribe for more explorations into the hidden intellect of history and share your own thoughts on their most clever tactics in the comments below.